Hello, everybody, and welcome back to our next session. This one is called Digital Platforms Taking API to Production and Microservices Patterns. So let's welcome Kanchana Wickremasinghe. And Kanchana, welcome. Thank you for being with us here. We are very excited to have you here this time. And why don't we proceed? First of all, if you can give a little introduction of yourself, and then right away you can proceed with your presentation. Thank you again.
Thanks for that welcome, Mariana. So I'm Kanchana Wickremasinghe. I live and work from Melbourne, Australia. I belong to a company called WSO2. Most of you have been in the API integration world, probably know the company. I've been with the company for about nearly 2 years, and I am one of the VPs and GMs for Choreo Business Unit. Choreo Business Unit is a business unit that looks after the new SaaS product that we have created called Choreo, and that's me. And that's my email address if you wanted to contact with me or connect me with LinkedIn or Twitter. And without further ado, I'll take you through the slides and let's get started. So Mariana highlighted the talk, which is about digital platforms, taking an API into production and microservices patterns. I did add a couple other things as well in obviously talking about how we connect them all together and how they complement each other. And obviously, time permits, we may have a few more minutes at the end of the talk to get questions. So what are digital platforms? So before going to talk about digital platforms or give a high-level overview of what's a digital platform, I wanted to take this quote and talk to you about what's the meaning of the platform and why it is important. So let me slowly read it out to you. This was by David Gray, who is actually one of the famous persons who came up with this quote. A platform is a support structure that increases the effectiveness of a community. This happens in our community as well as this happens in our digital world. So when we refer to a platform, it's a supporting structure that is making effectiveness in digital world, of course, in the digital community. Now, when you remember that, whenever I talk about the platform, just think about it and whether that actually really resonates. So why a digital platform is needed today? The world has obviously evolved from the mainframe era into the era where we are in, which is obviously a lot of people keep on referring to as the cloud native era. And this will keep on changing as well. Who knows? Metaverse keeps coming up, and maybe we get devices, software ready to be in a metaverse in few years. But right now, we're in the cloud native era, right? Why then it's still a digital platform is needed, right? Today, in today's world, we are experiencing a lot of digital experiences. We do need to get things in real time. We expect predictiveness. We accept where it need to be. Like if you are shopping or if you're going somewhere, we needed to know where we're going, what's the locations, etc., and also to be more personalized, right? So our sales, this is Asanka Basing, our CTO. He actually explained this very, very nicely, saying our cells living in this digital world called the digital bubble. So if you ever get a chance to have a look at his some of his blog posts and also some of the talks as well, which talks about this digital experience, and hence why we today needed a platform so that we can actually cater for these needs, right? So in a really, really high level, what are the core components of a digital platform? So I talk a little bit about the experience that you are going to expect, and next I'll talk a little bit about the platform core capabilities, right? So from experiencing the platform, it could be web, it could be mobile, sometimes it could be even IoT devices, or in this case, even API products, right? What does the digital platform consist of? It consists of at its core APIs, services, integrations, and identities are core fundamental components of a digital platform. In a foundational layer, you would have like a marketplace, the development you do, of course, operations and governance, right? And all these in a cloud native era, we would put it into cloud native infrastructure. It could be cloud native infrastructure in a public cloud, could be private, or in some cases, it could even be on premise. Obviously, on premise has limited capabilities. However, most of the cloud providers and private cloud have a lot more services to offer. So, in a nutshell, that is what it is from a digital platform perspective and their core components. Next, I will be talking about how to get a digital platform. You can either build it with the toolbox if you have the funding, if you have the will, and if you have the right teams. You could utilize various solutions from cloud providers like AWS, Azure, GCP, starting from source repositories, CI/CD, container registries, API gateways, etc. There's a lot of services that you need to put together to build what I showed you in the previous slide. Also, you can do this by open source tooling if you're wanting to do it yourself in-house, that you don't have access to the cloud services. So you could use things like Git, Argo CD, Harbor Registry for Container Registry, WSO2 API Manager, or Kong or Tyke from API management perspective, and the list goes on. You can do it together. So on the left-hand side, I talked about how to build a platform by yourself. On the right-hand side, I'm going to touch a little bit on about some available platforms, digital platforms that you can use as a service. Harness is one of the ones that provide the CI/CD capability. They have added few more features as well. It doesn't still give you a full end-to-end digital platform, but most of it that you would otherwise have to build, you can get out of that. Similarly, Humanitech as well. They both are commercially available products. They're also known as internal developer platforms. And the one that open source one, which is called Backstage, it's a CNCF, Cloud Native Foundation project, offered to them by Spotify. You can use that as well. Obviously, you have to host it and manage it yourself. Or you could use something like Choreo, which is a complete end-to-end digital platform. These are the choices you got. If you have the team, the willpower, the funding, etc., you go build yourself. Or if you just want to consume because you don't want to spend time in building a platform, you can do that as well on the right side, the platform that I explained. Now let's take a look at taking APIs to production. So whenever I ask somebody, like what it takes to take an API to production, most of the time, that's why I highlighted in the topic as well. Most of the time, and some obviously tell me the whole story, but most of the time they're thinking about the source and the API management software. They're thinking about the configuring of the API the API management software, securing the API, testing the API, and deploy it into production. Right. However, it's kind of right at the end part, not the full story. Hence why I think it's important for us to take a look at what's the entire life cycle of taking an API to production means. So from the left side, you define your requirements, then you start designing your architecture. This can be an iterative process. It doesn't have to be a waterfall. It can be agile. It can be an iterative process. You then start selecting and prototyping technologies, etc. And then you do go and build a environment. And this environment could be in a digital platform or services that you put together yourself. And then obviously the part in orange, which is the part that you actually start, building your code. This what I call the back end of an API. Right? And then you obviously start testing it, and then you go into configure it and deploy. And this is where CI/CD and other tooling that will get used. And at this stage, you will also start defining how to secure your API, and the API lifecycle actually comes in that stage. Once you do that, obviously on day one, you deploy that into production, but you can't forget it from there, right? Because you need to continue to manage your API that is in production. So you need to observe, you need to do maintenance, and this is an iterative process that will continue to happen, right? This is why I think it's important whenever you think about taking an API into production, you actually think about the whole life cycle, not just the life cycle of managing the API once it's in production. Right. Next, let me go over some of the microservice patterns. This itself is a big topic, so I'm not going to cover all of the patterns, but I'll touch briefly about what a microservice is, and then I will go through some of the categories and some of the patterns that are used in the industry, and some of the emerging patterns as well, of course, and then maybe go through some of those patterns in a little bit more detail, and then obviously we'll talk about it. So what are microservices? Credit to microservices.io. I have taken these diagrams. So microservices is an architectural style or an architectural pattern, right? That is used to independently deploy those services. They're loosely coupled. So as you can see from the diagram, previously what are called monolith, we would have had the account service, the inventory service, and shipping service, shopfront, all as one big e-commerce platform. If you look at something like Magento or PrestaShop, they are built in that way, right? Obviously, they call it modular, but they're still built in such a way that's more monolithic compared to a more modern microservices architecture style. So they're loosely coupled. They're organized around a business capability, or you could call it a domain capability. And the other thing is they are also owned by a very small team. Very small team means they actually take that whole life cycle I showed you early all the way to the production and manage it once in production as well. So Toyota a long time ago came up with this small term idea. Obviously, in the IT world, AWS kind of capitalize it, and they call it like the two-pizza team, which is about 8 people, maybe maximum 10, but no more than 12 people. Right? It's a manageable size, small team that own these services. In terms of patterns, I talk here about the different categories and some of the patterns that are involved. Like for example, from a decomposition perspective, it can be in domains, like I explained earlier, or it can be even subdomains. Because sometimes the payment domain, for example, for like a bank, it can be a really, really big domain, which is very hard to give it to one team. So you would ended up breaking down into smaller teams. A triangular pattern, a pattern that would use especially in front of legacy systems where you can't break it down like a core banking system, of course, can't break it down into small pieces. So you would put a triangular pattern in front of it and then expose that into, probably their mobile banking applications as a microservice, right? And that's a triangular pattern. And in terms of integrations, you use API gateways, use aggregators, and UI compositions, right? In UI compositions, you call it backend for front-end services. And in terms of what databases from persistent perspective, you could use a single database per service, like the diagram that we had earlier, or you could use a shared one. Shared ones are good if the shared database actually can handle near real-time transactions without actually overriding each other. To because we have these distributed services, things like Saga, CQR is evolved. I'll go, I think I may have a slide on Saga, so I'll take you a little bit over that. But those are kind of some of the database capability. Then obviously, like I said, taking it into production is one thing, that is day one or day zero, I call it. And then day one and day two is when you have to look after and maintain it. So from an observability perspective, you do need the tracing, you need the login, and you need to make sure that those services are up and running with health checks. And there are some cross-cutting functionality that you need to think about as well. How to externalize the configuration so it can be easily managed. How do you actually discover these services when you're in multiple different smaller teams and one person writes service A and the other person writes service B? If they need to discover them, you use this as service discovery. And things that involve taking these changes into production, we had to start think very differently from the monolith day to microservices. So we have to bring some new deployment strategies and patterns, things like blue green. So you would deploy in a completely new environment, test it, and make sure they are working before you cut over the traffic to the new environment that you have deployed, which is called blue green strategy, right? Or a canary style. You may deploy and send 10% of your traffic to the new service and 90% still to the other one, right? And that way you can know whether there are a lot of errors coming. If it's errors coming, you can completely turn the traffic off for the new deployment and use the other one, right? And the circuit breakers to make sure whether the service can actually do what it is supposed to do. If not, you can actually break away from it and then provide a reasonable answer to the consumer that was consuming. These are some of the patterns that are being heavily used in the industry, and some patterns are, of course, slowly emerging. Next, let me take you through the aggregator pattern, which is using an API, which is when you do microservices, especially like connecting into mobile applications, even web applications, you should typically use an API gateway to front end it for many reasons: authentication, authorization, security, etc. But importantly, this one will also prevent from lot of traffic that unwantedly coming into your services, lot of unauthorized access coming through, etc., right? So in this example, in this diagram, what I'm trying to show you is a mobile app that is exposed via an API gateway into multiple microservices. Sometimes, in this situation, you may end up talking to the backend individual microservices. Sometimes you might even have composite microservices as well. In the next example, how a service would use a single database. And these databases do not have to be the same. Depending on the service, you can select the right. Like the service A here has selected a Cassandra database that can go horizontally, scale. And in the service B, it's selected more like a document database, a MongoDB. And in the service C, we have selected more like a transactional one. So you have selected an RDBMS, in this case, a MySQL database. Now, does this pattern goes for everyone? Probably not, but these are some of the examples. Next one, the Saga pattern. Why the Saga pattern? So if we go back to that original diagram I had on multiple different microservices, taking the order, creating the order, checking the inventory, etc. Sometimes you do need to have a workflow to follow it through because we are now broken the monolith into a microservice pattern. So what that means is you may not be able to complete the whole transaction and get a result, right? So you have to have kind of a workflow. That's where the emergence of Saga pattern. This is credit to AWS, shows how an order is created and if there's a failure in it, what you do versus if it's successful, how you follow through. Now, putting this all together, what does that mean, right? So I'm repeating the, the diagram that I had in taking an API into production. So in the requirement stage, we define what an API will deliver, and then you go design and define the architecture of that API. And like I said, this is a repeating process. Okay, it can be iterative. It can also be waterfall. Nothing wrong with that as well, right? And then you prototype technologies. You either buy a platform or you build one. This is where you do that, and you go set up your environments like your development, build, test, etc. as well, and then you actually start writing the code. This is where you start actually building the API, right? What I call again the backend of the API, the business logic. You start testing your API, and then you start configuring and deploy it into production. And then obviously on day two, you start monitoring and managing it. Now, bringing this all together into a single diagram, what I discussed earlier, taking the API into production is the process from left to right, from requirements all the way to observing and managing on day two. Right. The microservices, the architectural style come into play when you start looking at the technology and evaluating and so on and so forth. And then obviously when you're in development, that is where your microservices style that comes into play. And why I put in dotted line as the emerging, there are digital platforms that actually start introducing likes of the architecture diagram, defining the architecture requirements as well. Not all of them, they can be independent and in another platform too. Nothing wrong with that. And then the from the architecture to taking it all the way to build, monitor, etc., is where your digital platform comes in. Now, if you remember in the slide about the digital platform, I said you can either build it or you can actually buy it, right? And this is where your digital platform would fit in. Right? Ariana, I think I hope I stick to the 20 minutes that's given to me. So if there are any questions
Yeah,
from the audience, I'm happy to take it. Otherwise, I'm happy to take some questions
yeah.
from you. Yeah.
Thank you so much. Yeah, we have a couple of minutes. So, what do you think is important to consider all the steps when taking an API to production?
For a couple of reasons. The first reason I think that a lot of the time when I talk to customers and even to developers, etc., they think about the last part of it, managing only the life cycle of the API versus that you still have to build the business logic and getting it all the way and the changes you have to do. That's why that full entire life cycle is very important when you're considering. And the second part is once you take it into production, you can't just throw it over the fence. You have to make sure that needs to be managed, maintained, observed, because that you're offering a service either internally or externally. That's why it's important.
Excellent. So, I think we have one more minute, maybe another question.
Sure.
Why are digital platforms or internal developer platforms becoming so popular?
They are becoming so popular because developers previously had to do a lot of these, I would call it infrastructure services, basically lifting all this hard work themselves to get something into production. Whereas with digital platform, enable them to focus on the business logic. They don't have to kind of worry about lifting and bolting nuts and bolts together, right? In a automotive sense, right? So they can focus on building that beautiful API, not having to worry about where to deploy, how to deploy, etc., because the platform gives you that capability.
Okay. So, Kanchana, thank you so much. This was brilliant. Thank you for
My
sharing
pleasure.
your time, your knowledge. And well, we hope to see you in a future event. And we let you go back to sleep because
Thank
it's
you very
time for
much.
sleeping in your time zone.
That's
Thank you.